Hi guys, welcome to Unit 41. Unit 41 is about planet Venus. I know we covered so far basically the Earth, also the Moon, and we're taking samples from the solar system. As I argued before, the course itself covers a lot of stuff in terms of planets, in terms of moons, in terms of basically objects also outside of the solar system. So we're taking items as we go along, basically, and expanding our knowledge about the solar system and the universe as a whole. So we started with the Earth. We took the Earth as a model of the planets in general, especially the ones in the solar system. We took also the Moon, which is the second biggest object on in the night, basically in the sky that we can see after the Sun. The third object in terms of size is, of course, Venus. Venus is the brightest star at night, after the Moon, of course. And it is the closest object to the Earth in terms of distance when the Earth and Venus are on the same side of the Sun. So this is actually a very, very important subject that we need to understand and study. There are some other underlying issues that we need to address in terms of Venus. The fact that it is similar in size to the Earth, it's slightly less than that of the Earth in terms of physical size. And also in terms of mass, it's not that different much from the Earth, in a sense that it's slightly less also than that of the Earth. In terms of the force of gravity, it's very close from the Earth. So there are some similarity between Venus and Earth. However, probably that's where the similarities end, and we need to understand the differences also. Venus is super hot. It's the hottest planet in the solar system, as a matter of fact. And also it has a super thick atmosphere. Its surface pressure is about 92 times that of the surface pressure of the Earth. So if you were to stand on the surface of Venus, you will be crushed under its own, basically, atmosphere. So this is some of the features that are completely different than the two planets. The other thing also is the composition of the atmosphere of Venus, which is mainly carbon dioxide, as opposed to the Earth, which is mainly nitrogen and oxygen. On Venus, is more than 96% of the composition of the atmosphere is actually carbon dioxide. And it has sulfuric acid also in the atmosphere, clouds of sulfuric acid. It has lightning, but it doesn't rain water. As a matter of fact, there is a small amount of water in the atmosphere, and also oxygen and some other elements. But the main component is, of course, carbon dioxide. The surface, as I mentioned before, is super hot. This is due to the, we know that from other studies, but actually the landing, the Russian Venera basically probe, when it landed on the surface, sent us readings of about 750 Kelvin. That is super hot, okay? When it landed also, it took pictures of the surface of the planet, and it shows that it has some volcanic basically rocks, indicating not too long ago, basically volcanic activities, at least in that area. Current studies actually indicate that there are some volcanic activities on the planet itself. So there are some similarities, as I mentioned in the beginning, between Earth and Venus. However, those similarities are small in comparison to the differences. We think what happened to Venus, that it underwent a greenhouse effect, and that greenhouse effect basically went for an extended period of time, and it was a runaway greenhouse effect that caused the planet to basically lose its surface water. Not too long ago, modern studies also indicate that the planet actually was not too different from the Earth. On the surface of Venus, there are lowlands and highlands. Most of these features, geological features of Venus, are named after famous women, with the exception of some mountain ranges in the northern, basically, side of near the North Pole of the planet, named after Maxwell Mounts. Anyway, So there were some shallow waters that for some reason, as the planet started to heat up, evaporated, and after it evaporated even further, that the water basically dissociated and broken down, and whatever left of carbon basically, I mean, whatever left of oxygen combined with carbon to form mainly carbon dioxide, and the hydrogen basically escaped the planet. So these are some of the differences. The other also big difference between the planets are two things, okay? The first one is the rotation of the planet. It is the only one that is in retrograde with respect to its own orbital motion. Its orbital motion is going like all of the other planets on the same ecliptic plane in the same direction, namely counterclockwise. The spin of the planet, though, is clockwise. So in other words, the sun rises in the west and sets in the east, as opposed to, for example, the earth, okay? That is one thing. The other thing also in terms of its rotation, it rotates slowly. If we were to monitor the day on Venus, it's going to take about 243 days for the planet to spin once around its own axis. 243 Earth days, that is. So it's slowly rotating around its own axis. Obviously, and there will be an assignment in here related to that. There is a discrepancy in here in the sense that because the planet is actually moving clockwise in it around its own axis, and at the same time going counterclockwise around the sun, the actual day on Venus is only 117 Earth days, but it's still, that's about half of its own year, because it takes about 225 days, I think, to go around the sun. So imagine you are on Earth and one day takes about 6 months. That's basically the situation on that planet. This slow motion caused an immediate problem, because in terms of the structure, it should not be different from the Earth, much different from the Earth. The first thing is it must have a core similar to the Earth in terms of composition and also size. And also that is the solid core and also the liquid core. And also in terms of the mantle, it has a mantle that has similar structure, namely silicate, rock silicate, and all of the other compositions that is heated up in the bottom and slowly, gradually cools down as it gets toward the crust. The crust actually on Venus is slightly thicker than that of the Earth. And the crust on Venus is not, at least the radar analysis does not show that it is made out of plates. So there is no plate tectonics on the surface of Venus to help basically dissolve some of that carbon dioxide. So the surface, again, is big crust. Of course, because of the volcanic activity, there are some ruptures here and there in it, but that's mainly the main structure. Now, since I mentioned the slow rotation of the planet around its own axis, and the fact that it must have a metallic, mainly iron composition inside its own solid core, and probably also in the liquid core, some iron nickel composition, the fact that it has a metallic core does not give it a magnetic field, at least nothing measured in terms of magnetic field, and that is probably due to its slow rotation. Okay, there are some problems right now. We're trying to understand the process itself. This is, for example, as we compare it to Mercury, which is also in a slow rotation around its own axis. And but for some reason, Mercury still has a magnetic field because the size of its core actually is very, very big compared to its own size. But again, there is no clear indication exactly why one is happening in one planet and the other one does not. So research is ongoing right now, trying to discover more and more about the planet. Again, the biggest problem to take away from this planet is the fact that it had a greenhouse effect, a runaway greenhouse effect that caused the planet to heat up. Could that happen to the Earth? Obviously, yes. because as I was saying, the two planets were not too different in terms of even surface structure not too long ago, about 150 million, anywhere from 150 million to about 450 million years ago. The two planets were identical, okay? So that is basically some of the features of the planet. Planned missions to Venus are still ongoing right now, including some landers, but also some balloon-based studies to see if we can somehow analyze the atmosphere of the planet, because up in the upper layers of the atmosphere, there are some suitable conditions in terms of temperature and pressure to sustain basically probes in those high levels of the atmosphere. So again, this is the unit 41. And I will follow up with another one on unit 48 and 47. Thank you.